Okay, so here is problem 2 of homework number 18, and I just fixed this. I actually put AP right here, but it was AB. That was 7 inches. But the rest of them, let's see. This is like a pair of bolt cutters, and the dimensions, this is 1.5 inch, 1.5 inch, 1.5 inch, and I made this 7 inches, and there's 15 pounds being placed on here, and we want to find out the force that's on the bolt. Okay, so let's see. And see, I also said that P was equal to 15 pounds. We want to find, all right, the force on the bolt. Oh, and I found my little, there's my little tiny pair of channel locks. See, isn't it a little pair of channel locks? Itty bitty pair of channel locks. I wonder what that red stuff is. Is that blood? Ah, it's a murder weapon. I don't know what that is. Yeah. Anyway, so it's a pair of channel locks. You can use it like a hammer. Boom, boom, boom on things. But that would have been better for the other problem. But here we go. Let's try to find this one right here. So we're going to use the fact that this is a two-force member to our advantage. Take the sum of the moments either about this bolt or about that bolt. It's probably going to be easier on this one right here. I think this is the one that we want to do. Although, no, wait, we have another thing. Okay, so there's going to be like maybe several equations right here. Okay, I think that's what's going to happen. I haven't really solved this one. FBD. I haven't solved this one yet, so it's be exciting to see what happens. I didn't do a great job drawing that. All right. Pencils come with an eraser for a reason. All right, so this is going to have like a line of action. We'll draw it something like this right here. Let's figure out what that line is right there. Let's try to figure out what this line is. I believe these guys are lined up too, right? Yeah. So let's call him beta. So we can find out what beta is going to be. Just rise over run, right? Tangent, and the rise is going to be 1.5, and the run is 7 inches. So we got 1.5 divided by 7 inverse tangent. Ooh, it's only 12.095. I'll keep 5 sig figs. Right there, right? When 1 is the first decimal place, good idea to keep 5 sig figs instead. So let's see, where else do we have? Oh, I guess I do have it. Okay. I was looking at this in a weird way. All right, so we have this right there, and then we have a force right onto there. So here's my reactions at C. I'll go FCX and FCY right in there. Let's see, we have our force acting right there. And so that's going to be our 15 pounds acting right on there. And let's see, the dimensions, we were probably going to go from right here. This is the FE. Should point that out. FE. This dimension is 1.5 inches right in there. This dimension from here to there. And there, okay. Right there, that's 1.5 there, right? Because I did say X right there, 1.5. And this one is going to be 7, so 8.5. Call it 8.5 inches. All right, but we have 2 unknowns, right? Oh, and by the way, this one's coming downwards, and this is probably going up this direction right here. I'm guessing. FA B. I'll call it FAB. This is a two-force member, so it's going to be the same in both directions right there. Okay. And let's see. Let's do this other piece right over here. All right, so here, this is going to be my FE as well, right? And let's see. Well, we'll have, we don't know any of these. I don't think this is going to help me at all. This FBD is not going to help me. But I put it on here anyway. I want F. This should actually be drawn in the opposite direction. Yeah. Because I already drew that one positive, so I'm going to have to draw this one in the opposite direction. Is that true? Let me think about this. Yes. FCY and FCX. And okay, so this is going to be F. So probably want to draw this other guy right in here. Yeah. Okay, so there was the secret to the thing. We could have drawn this guy first, and that would have, then we could have done about here, and that would have given us this. All right, so let me, I might even just erase this guy. This is going to be unnecessary, I think. This guy's going to be unnecessary. I should have been able to forecast this. But this is just a demonstration of the process of working through a problem that you don't necessarily know how you're going to get to the thing. And then you can have one of those little aha moments. Yeah, and I kind of messed that up a little bit, but I think it's going to look okay when in the scan. Here's my FAB right there, and don't, this is a good question here. Is there any is there any, no, okay. Yeah, so this is in line. Yeah, these guys are in line, so I kind of drew them a little off. Gotta be kind of careful with there. Once again, there's not a. All right, let me draw that a little bit over. Let me draw that over again. Something like that, and this guy is in the same line as that. Okay. And then I put him on there. Give him an arrowhead. There you go. And he's FAB. Right? And that's the same. That's the beta. Is right in there. And then we have this right here. Here's our 15 pounds. And here is forces. I'll draw them as positive. We're not going to need them. So this is FDY, FDX, right? So what I could do here, I'll set this up first. Some of the moments about C is going to be equal to 0. And what I'll find is I will have positive 15 times 1.5 and 8.5. That should be 10, right? Just like I had in the previous problem. But now I have 1.5 and 8.5 divided by 10. That should be 10, right? Just like I had in the previous problem. But now I have 1.5 and 8.5 divided by 10. That should be 10, right? Just like I had in the previous problem. But now I have 1.5 and 8.5 divided by 10. That should be 10, right? Just like I had in the previous problem. But now I have And then I also have in the negative direction FAB, but times the sine of my 12.095, right? And then also, so this is going clockwise, counterclockwise, right? Now here, this too is going counterclockwise, right? So I go plus FE times 1.5 equals 0, right? But I don't know FAB and I don't know FE. But now I can come down to here and say the sum of the moments about D is equal to 0. And I can say this is going to be clockwise, a negative 15. Oh, I got to get the distances here. So to D right there, right? So right there, and so this is 1.5 and 7. So this is 8.5 right there, right? And is this only 1.5? I made it look bigger than that. Okay. So that's going to be times 10. And then this is going to be plus FAB. So I'd probably do these out ahead of time. Do you think? No, I don't care. I like to do it this way. It forces me to like think through the things. And then the moment arm is 1.5. Oh, I forgot a moment arm up here. Duh. So this is 1.5 equals 0. Up here, this moment arm is going to be 8.5 to right there, right? Yeah, 8.5 up there. So I almost forgot that guy. Oops. Remember, some of the moments, it's got to be a moment. There's a force. There's the force that's in the vertical direction, but then it has to be times the distance, the moment arm to the distance. Okay, so based on this, FAB, and I'll call this equation 1 right here, FAB is going to be, so 150 divided by 1.5, but divided by 12.095, the sine. Boom. So this is 477.3 pounds. That's a lot. Woo! Because of that angle. And then back into equation 1, we have 15 times 10 minus 477.3 sine of 12.095 times 8.5. Let me see something here. That's interesting. That's going to be, because it's going to make it smaller, but this is going counterclockwise, and that's going counterclockwise. Okay. So let's see what happens here. FE ends up equaling, so we take the sine of 12.095, which that's going to be same thing we had before there, right? Times 8.5. So that's 850, right? But we're going to subtract out 150 from it, right? And then divide it by 1.5. So we get 466.7 pounds is what we're going to find onto this. I wonder if I messed anything up. There's a good chance. Seem to be a little accident prone today. But we have double check all these. 150. I think I have everything squared away. Interesting. Okay. Well, we will just write that down as being the answer. Mechanical advantage, by the way, is 466.7 divided by 15, which is an impressive 31.1. All right.